Welcome to the YouTube channel Teaching Learning. Today's topic of discussion is a theorem. The theorem says let P be a prime number. If P divides A square, then P divides A also, where A is a positive integer. To prove that theorem, we will make use of fundamental theorem of arithmetic. The fundamental theorem of arithmetic says every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. So let's have a look. Let's try to visualize and realize what it is. To understand the fundamental theorem of arithmetic, we have taken one example. So we can express 6 as 1 into 2 into 3. When you factorize, you will get 3 factors, and you can represent 6 as product of these 3 factors. So what it says, the first part in the first part says this theorem say in the first part this theorem says that every composite number can be expressed or factorized as a product of primes. So you can express any number as a product of primes. So you can express 8 as 2 into 2 into 2 product of primes. You can also express 18 as product of prime numbers 2 into 3 into 3. So this is the first part of this fundamental theorem of arithmetic, that every composite number can be expressed as a product of primes. Now, the second part is this factorization is unique apart from the order in which the prime factors occur, and this prime factor is unique, means that there cannot be other factors of 6. You cannot factorize 6 in any other way. It will always be 1 into 2 into 3. So any time you factorize, you will get 1 into 2 into 3. So its factor will be unique, or you can say factorization will be unique. You can express 8 into 2 into 2 into 2. You can express 8 as no one other than not other than 2 into 2 into 2. You can express 18 as 2 into 3 into 3. You cannot express 18 as 2 into 2 sorry 2 into 3 into something else. So its factorization will be unique apart from the order in which the prime factors occur. So here the order is not important. So you can express 6 as 3 into 2 into 1 also. You can express 6 as 1 into 2 into 3 also. So order is not important. Let's try to understand the today's topic of discussion, the theorem the theorem says let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. Let us prove it. To prove the theorem, we have supposed that the prime factorization of A is given below as A is equal to P1 P2 into P3 into P4 up to Pn, where P1 P2 P3 up to Pn are not necessarily distinct, means that they can be same, they can be distinct, they can be same. So what we have done is expressed A as a product of primes. Now it is given that P divides A square. Before that, A square can be written as A into A. So we have expressed A as product of primes. Now for each A we have written a P1 into P2 into P3 and P1 into P2 P3 into up to Pn. So A square is P1 into P1 P1 square, P2 into P2 P3 square, P2 square, P3 into P3 P3 square, and up it goes up to Pn square. To refer in other slides, we have named these two statements as statement 1, statement 2. Now it is given that P divides A square. P divides A square. It is given. So P divides A square. What it means? P is one of the prime factor of A square. To understand this, let's take an example. What we have done, I have divided 18 by 3. We got the result 6. So with no factor, with no remainder. So 18 is completely divisible by 3, and therefore we can express 18 as 6 into 3. So when any number divides some number, that means the dividing number is a prime factor of A square. So in this example, if 3 divides 18, so 3 is the prime factor of 3 is one of the prime factor of 18. So if P divides A square, P is one of the prime factor of A square, and it comes from fundamental theorem of arithmetic. Now we have written fundamental theorem of arithmetic to refer quickly when required. Now what we have got that A square is equal to P1 square into P3 square into P4 square up to Pn square. So here is the two here we had got the equation A square is equal to P1 square into P2 square up to Pn square. So you can I have put here to refer quickly. So what is the written here? A square is equal to P1 square into P2 square into P3 square up to Pn square. Now prime factors of A square are P1, P2, P3 up to Pn, and it comes from uniqueness part of the fundamental theorem of arithmetic. So you can see that P1, P2, P3 these are prime factors of A square. Now P is one factor from P1, P2, P3 up to Pn. What we had got the P is one of the prime factors of A square. So P is one factor of one factor. What we have got? P is one factor of A square, and what the A square is? A square is A square is this. So if P is one factor from this, what it means? It means that, remember uh, remember 2 points. First of one, the prime factors of A square are P1, P2, P3 up to Pn, and the second is that P divide you can say P divides A square. So we can surely say P is a factor of P square. And what we have said that P1, P2, P3 are the prime factors of A square. So we can easily say that P is one prime factor from P1, P2, P3 up to Pn. It can be anyone. P can be P1, P can be P2, P can be P3, and P can be Pn also. So I don't know which one from this list is P1. P can be anyone. So P is one factor from P1, P2, P3 and Pn. Now we have assumed that A is equal to P1, P2, P up to Pn. So if P is one factor from P1, P2, P3 up to Pn, we can easily say that P is any one of them. That means what? P is the factor of A. And if P is the factor of A, we can easily say P divides A. In this way, we have proved the theorem. So it is now proved. And what was the statement? The statement was, let P be a prime number. If P divides A square, then P divides A. And we have proved the theorem in this way. So if you have understand the topic, please like the video, subscribe to the channel and press the notification bell to motivate us. So please subscribe the channel.